Namaste all. Hope you all are doing good. Welcome to Namaste Crypto series and this is category 1 video 3. Category 1 cryptos terminologies explained and video 3 the topic of this video is what is gas? Why is gas? Everything about gas on the blockchain. Okay. Now I hope you have watched the video 1 about the blockchain and video 2 where we are covering various other terminologies and overall this is video 3 and I hope at the end of this complete explanation you will be getting more clearer picture about various new terminologies and there are many things, for example mining, which we have not explained so far, but that term is required, that the understanding of mining is required for understanding of the gas. So we have touched only the surface of those terminologies which is required as of now, but in detail the mining we are going to have a separate video. And with that mention, let's get started with all about gas. Why gas? So let's take a real world scenario and how it happens, and then we're going to compare the same scenario on the blockchain. Okay. So let's say in real world, this is Google Pay or Phone Pay, some sort of gateways, right? Now let's say public needs a service, that is, they want to transfer money from one account to different account. So they will ask the service provider that, okay, please provide me this service, and the service provider will provide the service in exchange of some transaction fees. Now in our real the gateways that we are using, some charges some fees, some charge some doesn't charges, and based on the type of amount or the type of accounts and the type of service that we are utilizing, there would be different transaction fees, right? Now here what is happening, public wants the service and there's a group of people who are going to provide the service. And why this all is happening, because the public who needs the service are paying some transaction fees or work fee to the service provider. And what is that service fee or work fee here? It is the actual money. Okay. So this is one real world scenario. Now the same thing when we compare on the blockchain. Let's say again we have a public which needs a service, and there is a blockchain network on which there is a payment gateway, right? Now when I want to say that I want to transfer money from one account to another account, we are just taking an example of payment as a service. Okay. So now on the blockchain there is a payment gateway and public wants to use that and ask for a service. Now public is transferring from one account to another account, but there is some execution, right? Money is moving from one account to another account, so there is some logic is getting executed, some executions are happening. So how this is happening? This is happening because the gateway is hosted or running on the blockchain. Now for this transaction to complete, who is going to complete? Okay. So who is going to complete? The miners. So we are not going to go in detail about miners in this video, but we'll have a one liner so as to get a clear picture of miners. So let's say miners are going to use their computation power and going to execute that service request which is placed by the public, that please transfer my money from one account to another account. So miners are going to use their computation power and going to execute the service request. Now why are they doing this? Because now when the public is asking for a service, they are going to pay some transaction fee to the EVM or Ethereum virtual machine or the blockchain. Okay. Now this transaction fee is received by the blockchain, and out of that some computation which is contributed by the miners to complete the execution, they are going to get the commission or the transaction fees. Okay. So basically fees is given to the blockchain, and blockchain in return gives some transaction fees to the miners because they contributed their computation and successfully able to complete the transaction. So that is the complete circle on the blockchain. Now here to understand miners, because we are going to use this term again and again, let's assume or consider as of now for our understanding that miners are nothing but some people outside who are using their computation and competing to complete some execution, or basically trying to work on the blockchain to get their commission, nothing else. Okay. So there is too much big concept for about the miners which we are going to take a complete demonstration, but here for our understanding, to move ahead and to get the clear picture of the gas, let's say that miners are nothing but people who use their machines like mobile, laptop, GPUs, CPUs or anything to contribute their computation and uh, like they work using that, and in return they get the commission. So that is how the real world and block on the blockchain we compare the context. Now again here we saw the transaction fees in the real world, which was money. So here what is it? It is nothing but if we're talking about Ethereum blockchain, it is Ethereum coin. Okay, now Ethereum coin is there, money is there. Okay, we understood the concept. Now, why gas? Again, the same question. So let's go back a step ahead. Now, Ethereum prices goes up and down. Now, why it goes up and down? It's just like our regular money, how the value of money or stock prices or anything goes ups and down. If the demand of for something is more, of course, its price is going to go up. If the demand of something is less, its price is going to go down. Okay, so let's come back here. Now ether prices fluctuates, changes, goes up and down based on the demand and supply. Right. For example, as soon as the NFTs got deployed on the Ethereum blockchain, the demand for Ethereum uh, increased drastically. Now, again, why demand? Because to perform anything on the Ethereum blockchain, you need Ether. Right. Now, to perform these kind of NFTs, sales, buys, and all, people needed Ether. Now, for that reason, Ethereum price literally skyrocketed. It meaning its price got increased. So that is just an example. So similarly, ether prices goes up and down. Now let's take an example that ether prices skyrocketed very much high. Okay, now if we say that ether price is directly proportional to transaction fee, for example, transaction fee for executing the specific thing is 1% of the total balance. Okay, so if ether price really skyrocketed, in that case transaction fee will also got skyrocketed, right? Now this is not good thing. If transaction fee is too much, people will really like, oh, for this much I need to pay a whole lot of amount. Oh man, no. Like basically, if the transaction fee is very much, the intention of using the platform or the intention of executing that transaction for the public, like the public does not wants to use it because the transaction fees would be very high, right? So if you are transferring 100 rupees and your transaction fee is 20 rupees, then will you use it? No, right? So similarly this thing. Okay, so if ether price is determining the transaction fees, then the transaction fees is very fluctuative, and it's not good thing for any platform. So for that reason, there is a separate unit that we that can be seen, which is called gas. So how the gas is calculated, how the gas's price is varying, and all those things we'll cover in a moment. Okay, what is gas is exactly we are going to say in a moment. As of now, we are on why gas. So now when the gas is coming into picture, we are saying ether is not determining the transaction fee, but gas price is determining transaction fees. So here gas price means what? What is the gas price of what? Who is going to buy the gas? Why gas and all? Again, we are going to take that in a moment. But as of now, let's say that ether price is not determining the transaction fee, but it is gas based on which the transaction fee is directly proportional to. Okay. Now, how this is operating will take in a moment, but because the gas is there, now the relation between Ethereum and the transaction fee is broken, basically decoupled. So that is the only reason why gas is present. Now let's move on to the next topic and see what is gas. So to do any computation or to do any work, there is some unit, right? For example, if you are from the development background, let's this example is going to be very suitable. But if you are from different background, let's say non programming background, then how will you compute that how much work have you done? It's basically like if you are building one block of house, two block of house, three block of house. So basically for every work there is some units, right? If you are like using or consuming a fuel for something, there would be unit like 1 liter, 2 liter, 3 liter. Similarly, there is a unit to measure a computation. So if you're from the programming background, then let's use this. But for the non-programming background, let's we have assumed that okay, you have consumed fuel, so 1 liter, 2 liter, something of that sort, right? So here in programmings, we have seen that we generally see what is the complexity of a program basically, and how many steps are we completing this action, or for this action, how much computation is required, right? So if you can see in the diagram, for this sorting algorithm, this is the best time complexity. This is the average. For, like that, we are comparing for different. Okay. Similarly, for any for execution of anything, even for adding two numbers, for subtracting two numbers, or making a big contract or anything, every activity needs a gas. Now, how much gas is required for each activity? That depends on how much computation is required to complete that action. So similarly, as we can see on the screen, like we have different gas requirement for different activity. Now most popularly or usually that we are going to see is the transaction. For the for the activity called transaction, 24,000 units of gas is required. We generally call it as 24,000 gas or 24,000 units of gas. Okay, now I hope you are getting a somewhat clearer picture that what is gas. It is basically the unit of computation. So here we have seen that for transaction purpose, the unit or the computation that is required is equivalent to 24,000 units of gas. Similarly, we can say for adding this much is the unit of gas requirement. Now this is never going to change. Okay, so let's say to add to two numbers, we need to get first number, we need to get second number, and we need to add these two numbers. So basically that was three steps. Now whatever is the price of anything, whatever is the machine that you are trying to add, it there might be many things that can change, right? But the number of steps that is required to do this computation is fixed. That is number one. Number two, add two things, right? So that is what gas units we are calling. To do this activity, this much gas unit is required. To do this much gas unit. Now this is never going to change. It's basically in how many steps can we do this activity, these many steps or these many units. Okay, so units of gas is fixed for any specific operation, but what is variable is here is the amount of price that we need to pay for each unit of gas. Let's take this as an example. For transaction, uh, let's take the simplest thing. For addition, we need 3 unit of gas. This we are taking as an example. So today, let's say 1 unit of gas is $1. It means for adding one thing, I need to pay $3. Okay. So tomorrow, it's still 3 units of gas that I require to add, right? But at that time, the each unit price of gas, like each the price of each unit of gas is $2. In that case, I need to pay how much? $6. So it's basically the price of gas that is changing, and how that is changing, who is deciding, and all, we'll take that in a moment. But basically here, the units of gas for any operation is going to remain the same, but the price of the unit of the gas, that is varying. Okay, I hope the concept is clear as of now, that what is gas. Now before moving further ahead, here the takeaway that we are taking is the units of gas is going to be remain same, but the price of each unit of gas, that we call it as gas price, is going to vary. Now how, what, who, etc., we'll see in a moment, but before that, let's see this, that there is something called units of Ethereum. Now, if we can see, 10 to the power of 18 way is equal to 1 ether. So here we see different units of ether. Just like 1 kg has grams, milligrams, and maybe more or less, like 1 liter has 1 ml and half liter, and so different units, right? Similarly, the smallest unit of ether is called way. Okay, and then we have kiloway, m way, g way, micro ether, milli ether, ether. Overall, you can see how many ways together combine the different units. So 1 way is equal to 1 way. Now 10 to the power of 3 ways means 1000 ways, nothing but k ways or kilo ways. Similarly, 10 to the power 18 way is nothing but ether. Okay, so I hope this units are clear. This is very much required to further go ahead and discuss about the gas price or the price of 1 unit of gas. Now, when we are discussing about the gas price, and if I say that as of today, the price of 1 unit of gas or gas price is 1. So I am not mentioning how many units. When I simply say 1, it means 1 G way. That means 10 to the power of 9 way. Okay. So the units in which we talk about gas prices, G way. Okay. Now let's talk about the gas calculation. Now we see gas price is the price that we pay per gas unit, and we have repeated this sentence so many times that as of by this time, like it would be giving you some clear picture. Okay, so how we decide how much we are going to pay or how much we need to pay for executing the specific activity. For example, adding two numbers. Okay, so we have seen that for adding two numbers, we assume that 3 units of gas is required, and for each unit we assume, let's say, $1. It means 3 units into $1, that is the gas price of 1 unit, or the gas price, that is the price that we need to pay for 1 unit of gas. So gas price into gas quantity, that is units of gas that we are using. So this combined will get gas cost in ether. Now gas price in our case is $1, and gas quantity in our case is 3 units. So $1 into 3 units is going to become $3. But in our case, gas price, when we say one, it means 1 GVA, as we have seen previously, right? So 1 GVA into 3 is equal to 3 GVAs. So that is the amount of ether that we are going to pay. So let's see how this is happening in a simple diagram. So sender decides upon gas price. Since we have seen the gas price could be 1 GVA, 2 GVA, 3 GVA, 4 GVA, 10 GVA, or anything. Okay, overall the center decides that I can pay this much gas price for this activity. Okay, so gas price is decided by the sender, and then he simply puts his request on the blockchain or the EVM or any blockchain. Okay, so basically he says that this is the price at which I want to execute this activity, and he puts it on the blockchain. Now miners take the transaction and start mining, or let's say start executing it, and finally the amount gets deducted from the sender. Okay, now here one more figure that we see is gas limit. So what is it? Because we are humans, we are definitely going to make mistakes someday or the other, in some way or different way, knowingly or intentionally or unintentionally, right? So to save us from this kind of human mistakes, we have something called gas limit. Let's say I have written a program and I want blockchain, hey, please execute this program. Okay, so I'm going to say that I want to execute this at 1 GVA, that is the gas price is 1 GVA, and I place it on the this thing what the blockchain. Now what happens, the ethereum is going to execute it and parallelly going to deduct it based on the computation or the gas units uh, that was taken up so far to complete the activity that is completed so far. Now here we can see gas price into minimum of gas quantity or gas limit. So that is, you have set the gas price, that is 1 GVA for our example, and you have also set a gas limit of 10,000. Okay, now the amount of gas that is required for the transaction is 3 units of gas, and the gas limit is 10,000. So minimum of 3 and 10,000 is 3. So it is simply going to consider 3 units of gas and going to multiply it with gas price and going to deduct it. But if let's say your activity is going to take 20,000, but for being on safe side you have set a limit of 10,000, it means it is going to consider the minimum of the gas that is required to execute the activity, which is 20,000, and the gas limit that you have set, which is 10,000. So in our case, minimum of 20,000 comma 10,000 is 10,000. So it's simply going to execute that much activity which requires 10,000 units of gases. So it will deduct 1 into 10,000, that is 10,000 GVA, and that is deducted, and only that much part of activity is completed. So it is not going to complete everything. So this is kind of safety precaution, because you might have huge number of balance in your account, and because of some mistake in your activity, it is taking too much gas. Now to safeguard you from any such mistakes, you are also setting gas limit. Though you know it requires 3 units of gas, you might set it up to 10 units of gas. Now unknowingly, for some reason, if your activity is taking 20,000 coins, because you set the gas limit, that is a safety guard, right? So in our case, it is going to take a minimum of the gas quantity that is required by the activity as per you, or basically the two things, gas limit that you set for the safety guard and the gas that is actually required by the activity. Now in general, when we are setting the gas limit, we know that this much it is going to need, let's say 10 it is going to need, but I'm going to set 20 as my limit. So whenever I set such thing, it is simply going to consume 10 units and it is going to return the remaining things. But if it goes because of some mistake 20, 30, 40, 50, because you have set gas limit to 20, you are safe. I hope now this thing is good for you. That is gas quantity and gas limit. Gas limit that is set by you. Gas quantity that is the number of units of gas that is actually required by the for the execution of activity. So I'm repeating this once again. Gas limit you set based on your understanding that this transaction or this activity requires this much units. For example, adding two numbers required 3 units, but for safe and for safeguarding, like for safe side, you set gas limit as 6 units. Just in case it requires some more few gas units, you set gas limit as 6. Though you know it requires only 3. And now when actually it executing, if it requires 3, it is well and good. Okay, it is going to consume 3 and it is going to return the remaining thing. But if in case because of some mistakes, if it goes on continuing more and more gas, it stops at the gas limit, because we see in the formula it is minimum of gas required by the activity comma gas limit. I hope now we have some clear picture on these two terms. So everything is clear, but you said that gas price is decided by the sender and it says one way. Okay. Now, oh, like we can put it as less as possible, right? Because gas price is decided by me. Why would I pay more gas price when I can simply have my activity executed in less price, right? Why would I do that? So we'll see how the gas price is decided, why the gas price goes ups and down, who decides it, and why do we even place activity with much more gas price when we can do the same in the less gas price. So let's take a step ahead and see that. Now, before taking this step, let's take a step back and one more demonstration or diagram. Let's see about this gas limit and gas needed. So, if you can see, gas limit is maximum gas that we are saying that the maximum gas that you can consume is this much. That is max gas that can be consumed for a transaction if something goes wrong. Okay, gas needed is the actual gas that is required for the execution of transaction or activity. Now in case the gas required is more and you place the less gas limit, it means the amount of gas that is required for the activity, you did not provide that much, so the activity is not going to complete. It is going to execute only that part of the activity in which the gas limit covers, and the remaining not. So overall it is red, that is the activity not completed. In case the gas limit is more than what the actual gas required, it will complete the activity and return whatever the extra limit that you have set or whatever the remaining coins that is left. Okay, now just for example how you set this price and what are the variables thing, this is a clear picture which I took from a metamask. What is metamask? Let's put that aside. But as you can see, there is the gas price which we are setting, which is in G way, and then there is a gas limit. Okay, so if we can see 41833 is the gas limit, it doesn't mean that the activity does require 41833. It is possible that it requires only 40,000 gas, but we are setting more than that just for the safe side. Okay, and the 1833 which is extra, if that is not consumed by the activity, it is going to be returned. Now we are placing that at a gas price of 10 GWay. To answer this question that why gas price cannot be put at the least possible value, let's say one way, and why it is increase or decrease and what factors are getting affected, we need to understand the complete process or complete picture. And as part of that complete picture, so far we have discussed only small part of picture. Now let's take a big picture and then we'll answer this question, or you will be able to answer that question. Okay, so we can see that after a moment we'll be able to answer questions like who pays gas, when is gas paid by the sender, who receives gas, when does miner receives gas. So these four questions you will be able to answer in a moment. Now there is a sender who is going to decide what is the gas price and what is the gas limit. Okay, so there is one part, there's one entity. Okay, now there's a second entity called mempool. Now what is happening here, basically whatever the sender wants the activity to be executed or the request that a sender wants to place on the blockchain, that will goes into the mempool, and there is so the mempool is a second entity. Now there is a third entity called miners. As we have seen previously, these people are going to use their computation and try to complete the service requests that are coming from the sender, which is already there in the mempool, and finally they are going to get the commission for the work that they have done, or the transaction fee, we can say. Okay, now once this activity that is placed by the sender and completed by the miner is actually completed, it goes on to the blockchain. Okay, now let's answer these questions. Who pays gas? We have seen sender on the utilization of computation, that is the computation which is consumed by the sender, meaning the computation that is used by the blockchain to complete the activity placed by the sender. Okay, so when that actual computation is consumed, only then the balance is detected from the sender. Okay, now when is gas paid by the sender? It's basically on the resource utilization or computation, or whatever the unit of energy. It's basically the computation energy in our case, that is in the blockchain. Now who receives gas? Only one miner who wins the competition. So why we are saying one miner? Because there would be many people, many machines basically competing against each other, that I will work for this, I will work for this. So there is specific milestones or specific targets that are kept to see which miner completed which activity, and accordingly they will get paid. Okay, so who receives gas? Only one miner who wins the competition. So if you don't get the complete picture of miner, because we have not discussed about miner, don't go into detail of miner. We'll have a separate demonstration coming after this video. So as of now, just assume the person who used his computation and completed the activity successfully, and also first among the all the competitors. Okay, so that one miner is going to get the commission. Now when does miner receives the gas? Only after successfully including this transaction in the block. It means that the final target of the miner is that you complete the activity before anyone else does, you reach this milestone, and then you can put it on the blockchain. So as soon as those targets are completed and the miner is able to put that activity or that successful activity log on the blockchain, it means that miner was able to complete the activity with required targets and milestone, and that's how we can say that this miner won. So he or she is going to get the commission. So when does miner receives the gas? On successfully including the transactions in the block. Now I hope the picture so far is clear. This is the big picture, right? Now coming back to our base question with which we have started all this understanding is, how or who uh, decides the gas price? What are the factors that we can say is gas price decided upon? Because in our normal understanding what we have seen so far, I can set the gas price to the least possible price, and I want my activity to be executed in the least price, right? So I don't need to pay any more transaction fees when I can complete my activity in least possible transaction fee. So let's go to this fee model, okay, and see how the gas price is decided and why this could be more or less. So we can see this main pool in which all the transactions are kept, or basically all the services are placed. Here I'm just giving that for example I'm taking, there is a T1, T2, T3, T4, different transactions overall. Let's say we got 10 services or 10 transactions which are placed on the main pool. It's not in the blockchain as of now, it's on the main pool. Only after successfully completing that activity it goes and be stored in the blockchain. Okay, so in our case there are 10 transactions that we see. Now these 10 transactions get sorted, or we can say it gets arranged in the order of its gas price. This gas price is decided by the sender. So if we see, there is T10, that is transaction 10, for which the sender told that I want this to be executed at 7 GWay. There is transaction 1 which is placed on the main pool saying that please execute this transaction at a unit of, at a gas price of 6.5 GWay. Okay, here we are not talking about how many units of gas. Here we are talking about gas price, that is the price at which the price that is paid by the sender for consumption of each gas unit. Now T2, T3, T4, finally we see T6, which the user said, please execute my activity at a gas price of 1 GWh. Now if we see, the gas price of different things is different, because every sender will have his own priority and will decide gas price accordingly and will put it, right? Now the miners, let's say miner can execute 10 gas units. So what is the most benefit for him? He will try to solve or perform that activity in which he or she can get maximum profit, right? So let's say transaction 10 requires 3 units of gas, transaction 6 also requires 3 units of gas. Now the miner needs to work the same 3 units, whether it is a T10 or T6, but if he works on T10, at that time he is getting 7 GWh for 1 unit of gas, right? But in case of T6, he or she is getting only 1 GWh. So which will the miner choose? Of course, the miner will choose to execute or complete that activity for which 1 unit of gas price, that is 1 unit of gas is maximum, that is gas price for which it is maximum, right? So in our case we can see T10 will be executed, even T1 will not be considered because T10 they are getting more profit. Okay, once the T10 is completed, now we can see they will go for T1. So I hope you are getting a clear picture. The more the gas price, the more the miner will intend on completing your activity. So it's basically, if you want your transaction to be executed as fast as possible, it means it needs to come on top of your arranging order. That means it needs to have the best gas price, right? So if you have no urgency, no emergency, it's fine if it takes some time to for the transaction to get completed, then you can put gas price a bit less. Okay, that is fine for you. But if you put, let's for take for example, just for a scenario that there is zero z way that you kept, it means it would be kept at the bottom of this uh, meme pool, right? And now no one would be showing any kind of interest to complete that activity or to like basically contribute their computation power to execute your transaction which is having the least gas price. So that is the scenario. People will decide what is the gas price I need to put. Okay, now there is one more thing. You want your transaction to be executed quickly or slowly, that is fine, but what price do you decide? It is basically based on the demand or based on what others are placing, right? If everyone is placing 1 GWay and you want your activity or transaction to get executed quickly, then instead of putting 10 GWay or 100 GWay, it is fine that you keep it 2 GWay. Still, your transaction would be considered as a first priority, right? So basically, to decide a price, you know that whether you want it quickly, slowly, or medium, right? But that is one factor. How quickly? Second factor is what price. So that price is dependent on the market price, or we can say demand of the gas price, or how what gas price is getting executed as of now, what is the gas price at which people are placing their orders currently. Now you don't know this, right? So basically whatever platform you are going to use it for placing these orders and anything, for example wallets. So if you are using the wallet to place these kind of orders, wallet will suggest you that this is the current gas price that is going on in the blockchain. So this is the suggestion for the fast, this is the suggestion for the medium, this is the suggestion if you are in no hurry. Okay, now based on that you can take a call whether you want to place it now or you want to place it some other time. Okay, because you are in no hurry, and even the slowest possible mode is not affordable for you, then you can wait for some time, because these prices again going to fluctuate based on the number of transactions or the demand of congestion that is going on in the network. Okay, let's take one more example. If suppose blockchain has very less capacity remaining, so because of huge amount of requests that is coming, right? So that is called congestion. It is not able to serve the public request because of huge volume of the request that is getting placed, right? So in that case what can happen, the gas price would be increased drastically. It means now people will not place their service request in such huge amount, right? So that volume will be reduced. Now the blockchain is able to handle the volume that is getting. So because of this congestion, again the gas price goes up and down. So basically, with the help of gas price, the blockchain is going to handle the demand, okay, of how much it can compute, of how much we can allow the people to use this, and etc. Okay, now there are many ways of reducing the gas price or increasing the public, because public are going to use it more and more. The more familiar they get, the more comfortable they get, they are going to use it more and more, right? So there are many new ways that are coming to have like to acquire or to serve as many requests as possible with reduced gas price. So those are different techniques, but here, because of gas price, blockchain is able to handle the congestion or the volume or the service that is getting placed. So that was about the fee model. Now if we go back and see this big picture again, I hope you are getting that how did a sender decided a gas price, gas limit, and it came on to mempool where miners decide which activity should it execute based on the gas price, and finally the activity completes and placed on the blockchain. Okay, so placing on the blockchain, because as we have seen the concept of blockchain, that it is immutable, non-hackable, it is for maintaining the records, tracking the records, and all such things. So basically the logs, let's take blockchain as a logs, that okay, at this time this activity was completed. Now he or she is successfully able to put it on the blockchain only after the activity actually completes. So because you understood this concept, we can take two more scenarios to understand that what happens if there is no transaction fee, what happens if there is a fixed transaction fee. So if you are good with the concept so far, you can move on to the next video, but otherwise let's discuss this for bonus understanding. So if there is no transaction fee, what will happen? People will use it left and right. Not only people, even the programs will try to use it left and right without thinking of any restrictions, because there is no charge, no one is charging you anything in case of no transaction fees. So to stop that, to stop the spamming thing, and if there is no such transaction, people will definitely spam, or machines will definitely spam. And with this, even various scope of various attacks will come into picture. For example, DDoS, distributed denial of service. So I'll try to use it so much that the blockchain will come to its capacity and it will not be able to serve the others. Okay, so that those kind of things will happen if there is no transaction fee. Coming to fixed transaction fee, of course the spamming or the DDoS will reduce to some amount. But what will happen here? There is a big activities which is there in the queue. There is very small activities which is there in the queue. Now because everything is having fixed transaction fee, even I will say I want to add two numbers, so I'll not wait for, I will not execute it immediately. I'll try to collect everything and I'll execute it in one activity. So I'll place a service request saying that I want to add these 10 things which are of different parts, right? So previously, because the transaction fee is charged based upon the gas or units that is consumed, we can think properly and place the request. But now since there is fix a transaction, I'll simply gather all the requests and place only one service request for completing of all my activities, right? So that is one scenario. And second scenario would be the prioritization will be gone. The blockchain will not be able to decide, basically miners will not be able to decide which one should I execute, which one should I not, because even I work for the big thing, it is a fixed transaction fee. Even if I work for small unit, it is same. So even if I contribute to the activity 1 which requires 3 units, I'm going to get only 1 GWay. If I contribute to the 10th activity which is requires 100 gas of units, I'm still going to get the same transaction fee. So why would I spend my 100 units of gas on completing the activity 10 when I'm simply get the same fee on the uh, activity 1 where it is require only 3 units of gas. So all the scenarios, so never ever will that big activity get executed. Okay, so the prioritization will be gone and miners will not show any interest in executing big activities which require huge amount of gas, right? So these are the two scenarios that we are just taking to understand. So Yeah, that was all about no transaction fees transaction, and that's where the fee model or the gas price or the gas units comes and resolves all such issues. So with that, we came to the end of this video. I am aware, or I think that is too much to digest. But if it is not, then excellent. You have much more capability to consume. But yes, it is too much to digest for uh, people who are beginners or who are just now trying to get a good grip of all these terminologies. And yeah, we are going to keep one step at a time, and I'll try to make content much more interesting going forward. Um, yeah, let's take one step at a time and we'll try to get full grip of it. And once we are good with all the terminologies that is required for going ahead, I hope you have seen the introduction video of this Namaste Crypto series, and there I've explained the step by step of what and how we are going to learn everything. So with that mention, let me know in the comment section if you have any suggestions about the content or the improvements that I need to work on how you felt about the presentations or explanation. Any queries, any other things, you can mention in the comment section. Apart from this comment sections of YouTube platform, you can also reach out to me on the Instagram, Facebook, and Discord, LinkedIn. You can find all even in the mail. So you can find all the links in the above section. I'll also try to include it as part of the description. And if there is any relevant links that I think that would be required for the referring or documentation, like the yellow page that we have seen to understand how much gas is required for watch activity, all those links I'll put it in the description. Feel free to visit and spend some time to read all those yellow papers, white papers as per your interest. But yes, most of the required things we have covered in this demonstration. So with that mention, do subscribe to support, follow me on Instagram, follow me on Facebook, and let's get ready for the next topics. Thank you.